In this video, we will discuss callable and future. Callable interface represents a thread that can return a value. It is very much similar to runnable interface except that it can return a value. So main difference between runnable and callable is callable returns a value. So if you need a program where you want to run a value, where you want to return a value, then use the callable interface instead of runnable interface. Callable interface can be used to compute status or results that can be returned to invoking thread. Future. When the call method completes, return value must be stored in an object in main thread so that the main thread can know about the result that the thread returned. For this, a future object can be used. It holds future as an object as a result. It may not hold it right now, but it will do so in the future once the callable returns. Thus, a future is basically one way the main thread can keep track of the progress and result from other threads. So you create a future object and then call either submit or invoke all, as we have seen in the previous example, and this future object will hold a value sometime in the future. And then what we do is that we can wait for this future object to get the value to basically have the value assigned to it using isDone or using .get. Methods of future. So first one is cancel, used to stop the task. Second one is get, used to get the result of the task. If the task is complete, it returns the result immediately. Otherwise, it waits till the task is complete and then returns the result. So get is blocking, and the third method is isDone. Returns true if the task is complete and false otherwise, and isDone is non-blocking. Callable and future example. In the previous section, we implemented sum of 5000 numbers in parallel using runnable interface. In this section, we'll be implementing the same example using callable interface. To complete the sum in parallel, we'll be creating a new class, sum of numbers, using callable. And inside the class, we'll be creating two callable threads. First one will sum the numbers from 0 to 2500, and others will sum from 2501 till 5000. We will run these callable interface using executor service. We will use intstream to create a list of 5000 numbers. We will use executor invoke all to get the results of individual callable and sum them up and print the total sum. Now let's implement this example in IntelliJ. To calculate the sum of 5000 integers using callable interface, let's create a new class, new, and then Java class, and the class name is sum of numbers using callable. And let's create an array of integer, public static integer array, and array is equal to int stream dot range close 0 5000, and then to array. And just for verification, we'll be calculating our sum and holding it in variable total is equal to int stream dot range close 0 5000 and dot sum. Now let's create public static void main using PSPM and create our callable thread. So callable 1 is equal to and integer sum is equal to 0, and for integer I is equal to 0 and I is less than array dot length divided by 2 and I plus plus. And sum is equal to sum plus array of I. Just waiting for, because for callable we have to return, so return sum. Now let's implement the second callable, which is callable 2 is equal to, and integer sum is equal to 0, and for integer I is equal to 0, integer I is equal to array dot length divided by 2, and I is equal to array dot length and I plus plus. I is less than array dot length. And here sum is equal to sum plus array of I. And here we are returning sum. Now let's create an executor service. So executor service executor is equal to executor dot new fixed thread pool, and we have 2 threads, so we are just creating a executor service with fixed thread pool size of 2. And now let's create list of callable, because we have those 2 threads, so we are creating a list of callable, and this will be returning integer, and task list is equal to arrays dot as list and callable 1 and callable 2. Now we'll be creating a future object. This future is future of integers, and this future will hold the results of our callable. Executor dot invoke all and task list. Complaining about invoke all, add exception, so add exception to method signature. Now integer k is equal to 0. This is for, we are using it for printing out, and let's define another integer variable sum. This will be holding the sum of both the numbers from the future. So sum is equal to 0, and for future and integer result and results, and sum is equal to sum plus result dot get. Add exception to method signature and printing out sum plus k plus is, so we are just printing out the individual sum, and plus result dot get. Now let's print out sum from the threads is plus sum and correct sum which we have calculated using int stream.sum is correct sum from int stream dot sum is plus total. Now executor service dot shutdown. So let's look at the program again. So we are creating two callable. So first callable will calculate the sum from 0 to 2500 and second one will calculate the sum from 2501 till 5000. Now executor service, we are creating a new thread pool of 2 because we have 2 threads. Now we are putting those two callable 1 and callable 2 in a task list of callables. And we are running using invoke of this task list, so it will go through this task list of list and will run all those callables. And then afterwards return the results and also a list. Now here we are looping through the list of results and summing the results from the result.get. So sum is equal to sum plus result.get, and then afterwards I'm printing out sum of 1 is this sum and sum of 2 is this sum. And afterwards I'm printing out sum from the threads is this and the correct sum from indexstream.sum is this, and shutting down the executor service. Now let's run this program. So you can see that sum from the thread is 1 to 5 and sum from the indexstream.sum is correct. So sum is correct and individual sum from the thread is, so this thread calculated sum of this and this thread calculated sum of this, and then afterwards these numbers were added together and then sum of the thread total is 1250250.